This is lesson 5-2, relations and functions. A relation is a set of ordered pairs. Simply, it's an x value and a y value. Okay? Relations are normally written with these little funky bracket things between them. So I could say 0 is 6, 3, 2, 4, 1, and put it in the little bracket things. That's a relation. Okay? It's just a set of ordered pairs, however many ordered pairs you want to have. A function is a relation that assigns exactly one output value, that would be your range or your y value, for every input domain value, which is your x value. For example, a function would be something to the effect of 3, 2, 4, -5, 6, 8. That would be a function because each x value I have is paired with a y value. If I have the same x value come up a second time, it must be paired with the exact same y value in order for it to be a function. So to see if something is a function, there's several ways you can look at it. You can look at it and say, do I have any repeating x values? If I do have a repeating x value, it better have the same y value as the first time it was listed. If it has a different y value than the first time it was listed, then it is not a function. The second way you can look at something is you can look and see if something is a function by doing what they call the vertical line test. The vertical line test is a method used to determine if a relation is a function or not. If a vertical line passes through a graph more than once, a graph is not a function. For example, I'll just sketch a little graph here. Here's a nice little x and y axis graph. If I have this little thing right there, that is a function because if I was to draw any vertical line, it only crosses the graph one time. Whereas if I had a graph that looked like this, again an x and y value graph here, let's say I have it going this way. If I was to draw any vertical line, look, that vertical line crosses it in two places. Therefore, it would not pass the vertical line test. Function notation is to write a rule. In function notation, you use the f of x symbol instead of y. Function notation means this. We're used to seeing something like y equals 2x plus 6. Function notation replaces this y with the symbol f of x equals 2x plus 6. It's just a fancy way of writing y equals. Don't let it confuse you. It's just another way of writing y equals. All right, one way you can tell if a relation is a function is by making what they call a mapping diagram. You list the domain values and the range values in order and draw arrows from the domain values to their range values. For example, we're going to determine whether each relation is a function or not. In A, we have the relation 3, -2, 8, 1, 9, 2, 3, 3, -4, 0. I'm going to list all the domains. So I'm just going to go down the line listing the domains. Domains are all your x values. Range is all your y values, just in case you can't remember that. So I have 3, 8, 9, 3, -4. I've listed them all. I don't need to list 3 twice because it's already listed once, so I'm going to erase it the second time so that it's only listed once. Now I'm going to write down all my range values. -2, 1, 2, 3, and 0. Basically, I have these are all my domains, these are all my ranges. Now I'm going to do the mapping part. I'm going to draw an arrow from each domain to its range. So 3 is paired with -2, 8 is paired with 1, 9 is paired with 2, but 3 is also paired with 3 down here, and then 4 is paired with 0. Once you have it mapped out like this, you can determine whether or not it's a function. Okay? Now that I've mapped it out, I can look at this and say, ooh, wow, I have 2 values. I have 2 y values for the same x value of 3. That cannot happen. If I have a y value of -2 the first time I have an x value of 3, the next time I have an x value of 3, I have to have a y value of -2, otherwise it's not a function. So this is not a function because we have 2 ranges for the domain of 3. 2 different ranges, 2 different range values for for the domain of 3. Let's look at the second one here. 6.50, 7, negative 1, 6, 2, 2, 6, 5, negative 1. I can list all of my domain values. 6.5, 7, 6, 2, 5. Now I can list all my range values. 0, negative 1, 2, 6, and I already had negative 1 listed, so I'm not going to list it again. These are all my domain values. Whoa, I almost missed. Fix that really quickly. These are all my range values. Now I can draw my little mapping diagram. 6.5 goes to 0, 7 goes to negative 1, 6 goes to 2, 2 goes to 6, 5 goes to negative 1. Now that's fine. I have negative 1 as a range connected to two different domain values. That is acceptable. That's perfectly fine. I can have two different x values going to the same y value. I cannot have two different y values going to the same x value. So this would be a function. Yes, this is a function. Because we have a one-to-one relationship. Each domain is paired with a unique range. Now, another way to determine if a relation is a function or not is to analyze the graph. If a vertical line will pass through the graph more than once, then the relation is not a function. So we're going to use the vertical line test to determine whether each relation is a function or not. So I'm going to take the relation 4, negative 2, 1, 2, 0, 1, and negative 2, 2, and I'm just going to graph it. Okay, so 4, negative 2. I go to the left, 4, 1, 2, 3, 4, down 2, or positive 4, excuse me, I almost went the wrong way. 1, 2, 3, 4, negative 2 goes here. 1, 2 goes 1 over 2 up. 0, 1 goes over none and up 1. And negative 2, 2 goes left 2, up 2. Now, if I was to draw any vertical line here, it would only pass through one point at a time, wouldn't it? So this is definitely a function. It doesn't, the green line that I just drew does not go through two red points at the same time. So this would be a function. Let's look at the second one over here. And I'm going to still use red and green. Nice Christmas colors anyway. 0, 2, up 0, or over 0, up 2. 1, negative 1, right 1, down 1. Negative 1, 4, left 1, up 4. 0, negative 3, left and right none, down 3. And 2, 1, over 2, up 1. Now, if I can draw even one vertical line that crosses two or more points, then it's not a function. So if I was to draw a vertical line right here, you will see it goes through two red dots. Since it goes through the red dot that is right here, and the red dot that is right here, which happens to be 0, 2, and 0, negative 3, this is not a function. It fails the vertical line test. If you know the input values, you can use a function rule to find the output values. So we're going to find the output values if we're going to use a table here for the f of x equals 8 minus 3x, and they asked us to use 1, 2, 3, and 4 as domain values. So I just drew a nice little table. I put my x on the left, I put my f of x on the right, and in the middle I gave myself lots of space to do the work for 8 minus 3x. Which means every time I see an x, I'm going to replace it with 1 the first time, 2 the second time, 3 the third time, and 4 the fourth time. So here we go. So I'm going to make my table of values. So f of x equals 8 minus 3x. So I'm going to have 8 minus 3 times 1. Well, 3 times 1 is 3. So it's 8 minus 3, which is 5. For x equaling 2, I'm going to have 8 minus 3 times 2. 3 times 2 is 6. 8 minus 6 is 2. When x is 3, I'm going to have 8 minus 3 times 3. So that's going to be 8 minus 9. 8 minus 9 is negative 1. And last but not least, when x is 4, 8 minus 3 times 4 is going to be 8 minus 12. And 8 minus 12 is negative 4. So I made a table when my domain was 1, 2, 3, and 4. My range is 5, 2, negative 1, and negative 4. You can use this function rule to give the domain and range of a function. After computing the range values, write the values in order from least to greatest. So my domain, is 1, 2, 3, 4. My range, the range of this function is not going to be listed 5, 2, negative 1, negative 4. You have to list them from smallest number to largest number. So my range is negative 4, negative 1, 2, and 5. So that's my range value. And of course, we should put these in little funky brackets that I'm terrible at drawing. Okay. All right, so here we have it below. It's going to ask us to evaluate the following function to find the range of the functions for the domain of negative 2, 0, and 5. So you could simply make a little table, just like the table we just finished. So I can sit here and I can say, okay, I have to make an x and y table. Leaves a little space in the middle to do some work. I'm supposed to use these values, so negative 2, 0, and 5. Okay, so when x is negative 2, I have negative 2 minus 6, which means y is negative 8. When x is 0, I have 0 minus 6, which means y is negative 6. When x is 5, I have 5 minus 6, which means y is negative 1. I have now found the values that I need, but now I need to list my range, and range is always listed from smallest to largest. So my range then, my range is listed as, on a little bracket, the smallest number is negative 8, then there's negative 6, and then there's negative 1. And that's my range. To make your range, and all you have to do is fill in your lovely table. And let's do it for the second one here. For y equals negative 4x. Again, have an x, have some workspace, have your y. Here it's going to be negative 4x. I'm still using negative 2, 0, and 5, because that's what they wanted me to use. So when x is negative 2, I have negative 4 times negative 2, which is positive 8. When x is 0, I have negative 4 times 0, which is 0. And when x is 5, I have negative 4 times 5, which is negative 20. So my range here, listed from smallest to largest again. Always list your range from smallest number to largest number. Is going to be negative 20, 0, and then 8. Oops, 0, then 8. And last but not least, we can graph, or we can do the table for the last value. Again, just make your table. Here, this is going to be t, and this is going to be g of t. Now, this should have been f of x over here instead of y, f of x. Okay, so we're going to have the middle is our workspace. This is going to be t squared plus 1. So when t is negative 2, when t is 0, and t is 5. When t is negative 2, remember when you square a number, you must put it in parentheses. So it's going to be negative 2 squared. Negative 2 squared is 4 plus 1 is 5. 0 squared is still 0. 0 plus 1 is 1. 5 squared is 25. Plus 1 is 26. So our range here is going to be 1, 5, 26. This is relations and functions. Being able to tell me whether or not something is a function, does it pass a vertical line test, and being able to find the range if given a specific set of input values or domains.